ASIMO, one of the world's most advanced humanoid robots. In many ways, Honda can best be defined by its pioneering research and development in advanced humanoid robotics. It requires state-of-the-art technology, a spirit of innovation, a dedication to enhancing people's day-to-day lives by expanding mobility, and a focus on serving customers and creating products that benefit society. In a world designed for humans, Honda's engineers first focused on developing legs that could walk independently. In 1986, Honda's first experimental humanoid robot, E0, took its first successful steps, but it was too early to say that the robot was truly walking. E0 took 5 to 20 seconds to complete each step, and it could only walk in a straight line. Known as static walking, this is different to the way humans walk. So Honda engineers looked closely at how people walked and maintained balance to better understand the mechanisms of movement. How do knees move when people walk? How much force does each joint receive? What's the average walking speed? In their study, Honda engineers found that when humans walk, they get just off balance as if they were about to fall forward. This walking while falling is very difficult to simulate in a robot, and it was a challenge in which no one had ever succeeded. In 1988, Honda engineers reached a key milestone in the E2 experimental robot by successfully imitating a human's dynamic walk. E2 could walk at a pace of a little less than 1 mile per hour on flat surfaces, and successive robots in the E-series made additional progress. However, all E-series robots lacked a torso, but with control of leg movements firmly established, engineers were able to move on to the next major challenge, creating a complete robot with a body as lightweight and efficient as possible. Research and development also expanded to refine the movements of the robot's arms and hands. These efforts led to the introduction of P1, Honda's first prototype humanoid robot, in 1993. Standing 191 centimeters and weighing 175 kilograms, it had a rugged appearance, but at last a humanoid robot had been created. In 1996, Honda engineers achieved a number of major breakthroughs in its second prototype humanoid robot, P2. Improved stabilization control technology provided more flexible leg movement. P2 could walk smoothly in any direction, walk over uneven surfaces and bumps, and even maintain its balance when standing still or when firmly pushed. And by wireless remote control, it could complete simple tasks, like pushing a trolley and tightening and loosening bolts. Standing 182 centimeters and weighing 210 kilograms, P2 now also housed all necessary operating devices. 9 months later, in 1997, an all-new prototype robot, P3, was introduced as the first completely independent, bipedal, humanoid walking robot. P3 stood at 160 centimeters and weighed 130 kilograms. P3 could walk at a faster pace of about 1.5 miles per hour, with superb balance and fluid motion, and its onboard brains now had the processing power of 30 personal computers. The next stage of the dream challenged Honda engineers to apply the company's traditional focus on the customer to create something that could function in an actual human living environment to better enable it to help people. The result was ASIMO, an acronym for Advanced Step in Innovative Mobility. Introduced in November of 2000, ASIMO stands 120 centimeters tall and weighs 52 kilograms. Compared to its predecessors, ASIMO achieves better balance, is more nimble on its feet, is even more stylish in its design, and is capable of a simple operation within a human living environment. ASIMO's height was an important strategic decision. The robot's eyes are located at the same height of those of a seated adult. Its size allows it to easily operate light switches and doorknobs, and to work at tables and computer stations. In ASIMO's walking abilities, Honda engineers again broke new ground. Where earlier robots had to stop to make turns, ASIMO has an unprecedented ability to walk and turn smoothly with Honda's intelligent, real-time, flexible walking technology. In addition to climbing and descending stairs, ASIMO can change step in midstream and walk faster or slower without required preset walking patterns as with previous Honda robots. With ASIMO, Honda's humanoid robotics program has entered an entirely new dimension in achieving flexible walking, simple operation, and a people-friendly size and design. As a technology and a development challenge, much work remains. But with ASIMO, Honda has truly taken an advanced step in innovative mobility.